Hello guys, welcome to my channel. So today we'll be considering questions, highly likely questions to come out in the forthcoming BC NECO math exam for the national GS3 exams. And these questions, if you're able to solve them on your own unaided, then your chances of scoring an A in the forthcoming exam are very, very high. So let's get into the material. The first question says to express this number in standard form. Basically, what you just do is to take this decimal point here and take it all the way to the very first non-zero digits here, this 4 here. Okay, we take it to the front of it. Okay, so how many times you do that, that determines what we write. So I'm just going to go 1, 2, 3, 4. So that's going to be 4.0089 times 10 raised to power negative 4. So 4.0089 times 10 raised to power negative 4, because I took it forward 4 times. So that is going to be the answer to this particular question. See how easy it is? Okay. All right, guys. So here is the second question. It is also on expressing this number in standard form. If you notice, the first one is different from this second one because it starts with 0.00. So it's an extremely small number. Okay, so what this means is that we can write extremely small numbers in standard form. We can also write extremely large numbers in standard form. This 256.26 now is quite large, even though it's not that very large, but it's large compared to the last one. And the procedure we use here is that one we took the point forward to the first non-zero digit. For this one, we're going to be taking the point backward here to the front of the very first non-zero digit. We're going to take it back. Okay, so it's going to go 1, 2. So it's going to be 2.5626 times 10. How many times did you take it back? Just 2 times. So that's going to be times 2. And if you remember, I didn't put negative here because I only have to take it back. Okay, if I have to take it forward, it will be negative. But I have to take it back because we are dealing with what? Numbers that are bigger than what? Than 1. Okay, that previous one was smaller than 1. So this is the answer. Okay, so this is number 3 question. It says to find the LCM of 30, 45, 60, and 90. The concept of LCM is the number that is big enough that each one of these can go in it. They can divide into it completely without any remainder. That's the concept of LCM. And logically, if you look at the options, look at 3 here. 30 cannot go in 3. 45 cannot go in 3. 60 cannot go in 3. 90 cannot go in 3. So 3 has been disqualified as an answer. Okay, let's go to 5. 30 cannot go in 5. 45 cannot go there. 60 cannot go. So definitely 5 has been disqualified. Look at option C. Yes, 30 can go in 60, but 45 will not go in 60 completely. You understand, with that remainder. So 60 has been disqualified. Let's go to 180. 30 can go in 180. It goes completely. 45 goes completely in 180 because 45 goes in 90 and 90 goes in 1. So 45 goes directly completely in 180. Okay. 60 goes in 180 completely. In fact, 90 also goes in 180. So that makes 180 the answer. I know a lot of people might want to consider 360 as also an answer. Yeah, it's one of the answers because all of them actually go in 360 as well. Okay, but we are looking for the what? The lowest common multiple. The lowest that is common to all of them. 180 and 360 are common to all of them. They can all divide, 180 and 360. But the lower of the two, or the lowest, is what? 180. So 180 is the answer. I mean, you can also decide to do, this whole thing that we are used to, but that's going to be taking time. In examinations, it's not only important that you know what to do. It is also important to know how to do it the fastest. Okay, so you may decide to do, the long traditional method of doing it 30, 45, 60, and 90, and then start, using prime numbers to take it all the way down. That's going to consume a lot of time. Okay, but if you know you can do that, no problem. Okay. All right, number 4 question. It says simplify square root of 225 all over 3. Guys, you need to know your perfect squares. You need to know your perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, all these numbers. So what number is going to give us 225, when we multiply it by itself? that obviously is going to be 15. 15 times 15 is 225. So this can as well be written as what? That's going to be 15 square root of 225. That's going to be what? 15 all over 3. And the answer is what? 5. Alright guys, welcome back to my channel. This is the number 4 question. It says find two numbers whose sum is 21 and such that 1/5 of the smaller is equal to 1/10 of the larger. So this question is a question on a simultaneous equation, okay, and I would advise you to pause the video, then give it a try, see what you can do with it, then unpause it and see whether your answer is correct. But get to see what you can do unaided first of all. Okay, so let's go. Find two numbers. Let's say both numbers are m and n. I want to use m and n, so it's going to be m plus n except is equal to 21. Okay, and such that 1/5 of the smaller, I'm going to say the smaller one is m. So 1/5 of the smaller is equal, you see, equal to 1/10 of the larger, is equal to 1/10 of the larger. The larger is going to be n. Let's call equation 1 and equation 2. From equation 2, sorry, this is equation 2. I can rewrite this expression as m all over 5 equals what? N all over 10. Then I can cross multiply. If I cross multiply, I'm going to be having 5n equals 10m. And from here, 5 is common to both. I can divide both sides by 5. If I divide both sides by 5, I'm going to having n equals 2m. So my n equals 2m. Now, if I go back to equation 1, n is 2m. So wherever I see n, I'll just put 2m. Therefore, equation 1 becomes what? M plus n. And n is what? 2m equals 21. So m plus 2m, that's going to be what? 3m equals 21. Divide both sides by m. I'm having 3m equals 21 divided by, divide by 3. Sorry about that. Divide by 3. So divide by 3, divide by 3. So 3 cancels 3. M equals to 7. So the smaller one, like I said, has to be m. Smaller one is 7. So the bigger one has got to be what? From equation 1, you can use m plus n equals 21. So m is 7, so 7 plus n equals 21. So n equals 21 minus 7. That should be around 14. So the smaller one is 7, the bigger one is what? 14, and those are the numbers. Okay, so on to number 5. All right, so the fifth question says y is inversely proportional to 1 over x, and y equals 6 when x equals 4. We have to find y when x equals 3. So very quickly, y is directly proportional to 1 over x. We need to find our k. Introduce our k constant is going to be equal to what? K all over x, right? Cross multiply to get our k. So k is going to be equal to what? K times 1 k. Y times x, that's going to be y x. All right. Now let's find the value of k. So k is going to be equal to, we are given y to be 6 and then x to be 4. So 6 times 4, y times x, 6 times 4. So k is got to be 24. Okay. We want to put k back into this equation. Okay, or into this equation. Any of these to work. All right. So therefore, 24 equals yx. I'm using this one. So now it says to find y. It says to find y when x equals 3. So therefore, it's going to be 24 equals y times 3. So 24 equals 3y. Divide both sides by 3. So we're going to be having 24 divided by 3 equals 3y divided by 3. So 3 can cancel 3. 24 divided by 3 should be 8. So 8 equals y. Therefore, y equals 8. And that's the answer to that. So let's move on to the next question. Okay, so the sixth question is the same thing as the fifth, but if you notice, this one is just ordinary x. This one is the square root of x. So let's go. We introduce y, we introduce our k, our constant of proportionality. So y equals k all over root x. Okay, we cross multiply as always, k times 1 equals k, y times root x, that's going to be what? Y root x. Now we substitute our values. So k is going to be equal to, they say y equals 3 when x is 36. That will be 3 times root 36. And k equals, of course, you all know what root 36 means. It's a perfect square. So that's going to be 6. So times 6. So k equals 18. Then we can put k back in this equation, okay, or back in the first equation if you want. So I'm going to put it back here in this equation. So therefore 18 equals what? Y root x. Now we are asked to find y when x is 45. So you say 18 equals y root 45. Okay. Of course, we know that 45 is not really a perfect square. Okay, so you can just say square root of 45. That's going to give us 6.7. So 18 equals y times 6.708. As we know, it must be 4 decimal places. Okay, 6.7082. Okay, so how do you now find out y? We divide both sides by 6.7082. So y is going to be equal to 18 divided by 6.7082. Or you can just say 18 divided by root 45. That will be your y. So that's going to be y is going to be 18 divided by square root of 45, and that gives 2.683. Let me leave it in 3 decimal places. So the question might still leave it in 3 decimal places or 2 decimal places or two significant figures. Question like this, they want you to they want to test your knowledge on how whether you can express your numbers in 2 decimal places or 3 decimal places or significant figures. So yeah, that's the answer. Okay. So q varies directly as r and inversely as square of p. R equals 10 when p equals 6 and q equals 3.5. Find q when r equals 9 and p equals 2.4. So here is joint variation, and as you can see, q varies directly as r, q varies directly as r, and inversely means all over p squared, because the square of p. Sorry, this is the square of p. So r is 10. You know, we have to introduce our constant of proportionality by first of all writing equal to. So q equals kr all over p squared. Then we want to look for the value of k. So we first multiply, it's going to be kr equals what? qp squared. So k is going to be divide both sides by r, and then qp squared all over r. Now I can now introduce substitute our values. R is 10, so that means k is going to be r is 10, p is 6, and q is 3.5. So there's 3.5 is q times p squared, which is 6 squared, all over there's r, said r is 10. So putting this in the calculator, we're going to get 3.5 times 36 all over 10. So 3.5 times 36 equals 126. 126 over 10, that's going to be 12.6. Okay, so that's the k. K equals 12.6. But the question now says, find q when r equals 9 and p equals 2.4. So we now know our k to be 12.6. We'll go back to this equation and put k at 12.6. So it's going to be what? 12.6 equals, they said q, they said to find q. So we're looking for q, and you're going to put q there, times r is 9, p is 2.4. So that's going to be 2.4 squared all over 9, right? So if I cross multiply to get 12.6 times 9, that should be 113.4. 113.4 equals 2.4 squared is going to be, that's by saying 24 squared. Just put in 2 decimal places. That will be 5.76. So 5.76. All right. Q. So how do I get my Q? Divide both sides by 5.76. So Q is going to be 113.4 divided by 5.76. So Q is going to be equal to 113.4 divided by 5.76. The answer is 19.68. They say to write our answers in whole number. It's going to be what? That will be 20. And that is Q. All right. That's the answer. All right. So the question number 9 says y varies directly, jointly as x and z. This is a joint variation, but it's direct joint variation. The previous one was direct and inverse. It was jointly, directly, and inversely. But this one is directly as x and z. All right. So I'm going to be writing it y equals, I'm going to be introducing my k. We're going to be k x z, right? And I'll be making k subject to the formula. K will be equal to, divide both sides by xz. So I'm going to be having y all over xz. Then I'll introduce my values. X is 3, z is 5, and y is 2. So k equals 2 all over x is 3, x is 3 times z, z is 5. So k is going to be equal to 2 all over 15. So 2 all over 15, that's my k. I'll now go and put k back in this equation. Then I'll just write it back. That's 2 all over 15 equals, now the question says to find y. Now we're looking for y. So I'm going to be putting y here. All over, what's my x this time around? X is still 3, just like the first time. And the z is 2 this time around. So I'm going to put in 2. So I'm having 2 all over 15 equals y all over 3 times 2 is 6. So cross multiply, I'm having 15y equals 2 times 6 to be 12. So y is 12 all over 15. You can decide to take it all to the all the way to the lowest term, or just express this as decimal. So 12 divided by 15 should be 0.8. So y is 0.8. That's number 9 question. Move on to, all right, guys. This is the 10th question, number 10, and it's study the formula. It says to express m in terms of n and x. Please, once again, guys, pause this video, try it unaided, then unpause it to see whether you got it right. Okay. So let's go. X equals 1 over 4 square root of m all over n. What we get to there, what we need to get first of all get rid of is this 1 all over 4 before you get rid of the square root. Okay. So I'm just gonna go. I can rewrite this expression as x equals this 1 all over 4 times all of this. It can be the whole of this all over 4. So I can do square root of m all over n, everything all over 4. I can put over 1 here. I can do like that. Then I can cross multiply. If I cross multiply, 4 multiplies x and 1 multiplies square root of m over n. So I'm going to be having 4x equals 1 times square root of m over n is the same thing as what? Square root of m all over n. Okay. So the next thing is to get rid of the square root. And how do I get rid of square root? I have to square both sides. Take the square of both sides. So if I square this expression, this 4x squared is going to be 4x all squared equals then square root of m all over n all squared. Okay, when I do that, then square and square root will cancel out. So I'm having, and if I open this bracket with this square, it's going to be 16x squared. So I have 16x squared. All right, number 11, guys. It says to factorize this expression, all you do is just multiply the first term by the last term. Okay, that's x squared multiplied by minus 3. We're going to be having minus 3x squared. And then we now find the factors of 3. These are just 1 times 3. Okay, and then we manipulate the factors such that we have minus 2 in the middle. If you add them together and we multiply it, we get minus 3 at the back here. So how do we do that? If we take minus 1 and then minus 3, that'll be minus 4. So we need minus 2. So let's take plus 1 minus 3. That's going to give us minus 2. All right. And 1 times minus 3 is also minus 3. So 1 and minus 3 are the factors we're going to be using. So what do you just go here, put x here, close the bracket, put x here. So plus 1 minus 3, just put x plus 1 and x minus 3. So the factors of this expression is x plus 1, x minus 3. And that's the answer. Alright guys, number 12. It says to factorize the following: 16x squared minus 4y squared, and number 13, 3a squared minus 27b squared. If you take a very good look at these expressions, they are both difference of two squares, okay? Remember, a squared minus b squared, right? Always equal to a plus b, a minus b, or a minus b, a plus b. The arrangement or the order doesn't really matter. Okay, so what we must ensure to do, is that the first, all the terms are perfect squares. 16 is a perfect square, x squared is a perfect square, 4 is a perfect squared, y squared is a perfect squared. So we are going to be taking the square root of each one of the terms. That's the basic concept of difference of two squares. So 16, what's the square root of 16? That's going to be 4 squared, x already an x squared, minus, what's the square root of 4? That's going to be 2. I'm going to be writing 2 squared. And what's the square root of y? Because y is already okay, just y squared. Okay, so what do you now do next? This is 4 squared, this is x squared. I can just put 4x inside the bracket and square everything, minus this 2 squared y squared. I can just put 2y all in a bracket. So it looks like a squared minus b squared. You see, d squared minus d squared. So this is going to be our a, this is going to be our b. Okay, and they're just going to factorize like this: a plus b, a minus b. So this is my a, 4x, and 2y is my b. So it's going to be what? 4x minus 2y, and then 4x plus 2y. So that's how we factorize that. That's number 12. And number 13, if you check 3a squared minus 27b squared, none of these expressions, none of these square coefficients is a perfect square. 3 is not a perfect square. 27 is not a perfect square. It's only a squared and b squared are perfect squares. So we have to find a way to make sure 3 and 7 are, they kind of eventually get manipulated to give perfect squares. So if you do that, if you divide 3 by 3, okay, let's divide 3 by 3, because 3 goes in both, in all of the expressions, right? 3 goes here and 3 goes here. So put 3 out, and then what's going to be left? A squared minus what? 3 in 27, that should be 9. That'll be 9b squared. So if you check the expression inside the bracket, it's a perfect square. It's the difference of two squares, because a squared is a perfect square. 9 is, 9 is a perfect square, and b squared is also a perfect square. Okay, but you need to express 9 in terms of its square root. So this expression becomes 3, open a bracket, a squared minus 3 squared and b squared. All right, so we have 3, open a bracket, this is already a squared minus 3 squared b squared. We can just take 3b,
and square everything. So you see, this expression has become a squared minus 3b squared. So this is going to be our a, and this is going to be our b. So how do we do that? We have a minus 3b and a plus 3b. Okay, and this 3 is outside, and that's how you factorize that. Okay, on to the next question.